All right. So, how do we create a confidence interval in the unusual case where sigma is known? Okay. I'll just show you this real quick but we don't really use this very often. The big thing about if sigma is known, then we use a different error formula. Okay. There it is. It uses z and the known sigma. So suppose we have this situation. We have n equals 15, so we have a sample of size 15, and these are birth weights. And the average birth weight of our sample is 30.9. Okay, we want to find the 95% confidence interval estimate for mu. All right, and let's suppose we know, and this is the big one, somehow magically we know, and I shouldn't say it that way, but we know that sigma equals 2.9. There are lots of populations that we know that people have studied historically for a long, long time. This is probably one of them, birth weights of girls, where we actually do know sigma. So it's not out of the realm of imagination to imagine that we do know sigma. All right, but we know sigma. All right, so finding the confidence interval is simply going to be this: you take your sample mean that you got from your sample plus or minus your error. And for your error, it's going to be, we'll just do this, right? It's the z score associated with creating a 95% confidence level. If you look in table 1. Or A2, it's 1.96 times sigma over square root of 15. Okay, so you're just using that same z-score that you used with proportions, because it was a z-score there, and we're just using that same z-score. We don't have to use t-scores, and we get 1.4. We get to use the same. We'll use the same number of decimal points as our summary statistics as the mean. The mean 30.9 has one standard deviation or one decimal point, so we get to use one decimal point in our so 30.9 minus 1.5 is 29.4, right? And 30.9 plus 1.5 is 32.4. Okay. Now, that gives you your confidence interval. Now, I'll just mention this because suppose because we had those two kind of odd formulas. Suppose I gave you the confidence interval, right? So suppose I don't know any of this stuff. This is kind of a different problem, but I gave you the confidence interval, and I wanted you to find the sample mean that was used to create the confidence interval. Well, you just need to find the number that's exactly in the middle of the confidence interval, right? And but the book gives us a formula. It's simply the upper limit plus the lower limit divided by 2. And of course, if you do that, you're going to get 30.9, right? We knew that beforehand, but there we go. The other thing is find the error. Suppose all you have is the confidence interval, and you want to know what the error is. Okay, the error is equal to the upper limit, 32.4 minus the lower limit, 29.4 divided by 2, and that's going to be 1.5. Okay, so if you have in the unusual case where they give you the confidence interval and that's all they give you, and they want you to find these two things, the sample mean and the error, then this is how you do it. Okay.